Hello everybody, this video is made for all Chemistry Leaving Cert students doing their Irish Leaving Certificate examination. All exam material used in this video is from the State Examinations Commission, and this question is 2012 higher level chemistry paper. Please note that this video only contains calculations and no theory is covered. Most of the students have trouble with the calculations and there's pretty hefty marks rewarded for it, so if you can get the calculations bit covered, this is an easy 50 marks for your exam guaranteed. And titrations come up every single year and it's question 1. So before proceeding, please make sure that you watch my video on the introduction of titrations. That will help you to understand some tips and tricks and where does some of the numbers come from, how do I answer the theory part of it. You might get some bits off from that video, and that's quite useful to watch before these calculations. And the second thing is, I highly recommend you to stop the video for each question and then do the question yourself instead of watching me do the question and the solution, so you'll know what you did right and what you did not do right. And that's the best way to learn, I think, peer review, peer corrections. Now, I said peer review because I'm a student myself. I'm in 6th year this year. So these are some of the tips that I've learned and accumulated over the past 2 years, 5th and 6th year. So it is quite relatable to each other, I hope. Alright, so now I may ask you to stop the video and try the questions, the calculations. So it's this question and these 2 questions. Try and do it if possible, and then you can do the peer review, the corrections. Welcome back. I hope you have tried this question. So the very first thing that you have noticed is the reagents that we use for this experiment. It's hydrochloric acid and anhydrous sodium carbonate. So if you watched my previous video over here, you would have noticed 3 different sections that I've divided all the titrations into, and this goes to the acid-base titrations. Now, acid-base, acid is a pH of 0 to 6, and base will be 8 to 14. The acid here would be your hydrochloric acid, also known as HCl, and your base would be anhydrous sodium carbonate. Make sure you say anhydrous. Sodium carbonate, Na2CO3. I've highlighted here in lilac, in purple color, all the number values, all the numerical values that you can see in this question, and this should be catching your eye in an exam situation. It's very easy to get confused and wonder what is happening. Is this belonging to the hydrochloric acid? Is this to the sodium carbonate? What is happening? Very first thing that you need to do is to understand which solution goes to the burette and which solution goes to the conical flask. And if you look at my beautiful, wonderful masterpiece of a work here, you can see, I don't know if you can tell, this is a burette and this is a conical flask. Usually I would go with this theory, and that is, acid above AA and base below BB. But that doesn't always work for all titrations, and that's not a really easy way to remember. That's not a reliable thing to remember. And I say that because in future titrations, like redox equations, you would not be using acidic or basic solutions, so you may get confused. So what I do is this thing called weird number, good number theory. So if you follow the acid above, base below, this should be hydrochloric acid, HCl, and your bottom should be your sodium carbonate, so that is Na2CO3. If you look at the question back here, make sure you read it very, very carefully. Now, if you look at this 25, that's what I call a good number. And this 20.8, I would call that a weird number. There's a reason why I do that. It's because good numbers have like a whole number. It doesn't have 0.0675 or anything like that. This is 20.8, so it has a bit of a decimal after it. So if I followed that logic, then the good number would be 25 cubic centimeters, and that goes to the conical flask. And the rather weird number goes to the burette, and that would be 20.8 cubic centimeters. And that's hydrochloric acid. That's hydrochloric acid. And your weird number, or sorry, good number, would be your Na2CO3. And anytime you see the word titer, that means that comes from the burette. So 20.8 cubic centimeters of HCl was needed to complete the reaction with 25 cubic centimeters of anhydrous sodium carbonate. And this 0.05 molar stands for 0.05 moles per liter, excuse my handwriting, of primary standard. You need to know the definition. It's a compound that we know the concentration of, and when you mix it with water, that forms a standard solution. So the solution of anhydrous sodium carbonate is a standard solution, and this belongs to the anhydrous sodium carbonate. Now that we know all of the housekeeping work, let's start doing the questions. So calculate the mass of anhydrous sodium carbonate Na2CO3 required to prepare this solution. If we read the question above, we know that some mass, we don't know, we are supposed to find it out, of anhydrous sodium carbonate was mixed with 500 cubic centimeters of deionized water to form a solution, a standard solution. And the moles we know per liter is 0.05. So how do you do this? First of all, you need to find the molecular mass of anhydrous sodium carbonate. So this is how you do it. This is the equation that you need to remember for this type of. I haven't seen this come up, but this is an unusual one, so it's good to remember this. So it's moles per liter, so that is 0.05 over here. Volume, which is 500, this one, and the molecular mass. How do you find the molecular mass? We come over here. Sodium carbonate is Na2CO3, sodium is 23, Na2, 2 of that, carbon is 12, oxygen is 16, multiply that by 3, O3, all of that together will give you 106. Now I'm just going to sub that all in. And when you put that all in your calculator, you will get 2.65 grams of Na2CO3. It's as simple as that. And that will give you 6 marks in total. Going back to the next question, calculate correct to 2 decimal places the concentration of hydrochloric acid in moles per liter and grams per liter. It's just like we had a value for anhydrous sodium carbonate over here, 0.05 molar, we're supposed to find out a number for hydrochloric acid. So that's the whole point of doing this experiment. Whenever you hear the word concentration, think of this equation, and that is V1 N1 over N1 equals V2 N2 over N2. I'm going to label each part. So this belongs to the hydrochloric acid, and this belongs to the sodium carbonate. V stands for volume, N stands for molarity or concentration, N stands for the number of moles or ratio. We know from our burette and conical flask situation that hydrochloric acid has a volume of 20.8, and your conical flask has Na2CO3, and that is 25. What do I mean by ratio? So if you look at this equation, they always give you a balanced equation. You can see there's 2 hydrochloric acid. I know there's nothing there, but there's a 1, there's an invisible 1. Na2CO3, 2 NaCl, H2O, and carbon dioxide. So this basically means for every 1 part of Na2CO3, I need 2 parts of hydrochloric acid. If I have 10 grams of Na2CO3, I need 20 grams of hydrochloric acid to complete our reaction fully. Our reaction ratio is 2:1, 2 hydrochloric acid for 1 Na2CO3. Okay, so I'm going to write that down. The volume of hydrochloric acid is 20.8. We're trying to find the molarity, so that's X. The reaction ratio is 2. For Na2CO3 it's 25. Molarity is 0.05. And the ratio is 1. Since it's an equals, we're allowed to cross multiply. So that would give you 20.8x equals 2.5. Now it's basic algebra. X equals 2.5 divided by 20.8, and that would give you 0.1201923. I know that sounds hilarious, but even the 0.05 difference can change your answer in chemistry. And X is equal to 0.12 molar, or moles per liter of HCl. I rounded off to 2 decimal places because the question asked you, if I can go back to the question, to do it in 2 decimal places. Remember, this equation only works for liters, so if the question asks you for 500 or 250, you will have to divide the final answer by 2 or 4 accordingly to get the moles per 250 or 500 and so on. Next question is to find the grams per liter. Again, sorry for the bad handwriting, I don't have a stylus. So, other than that, this triangle is the one that helps me through chemistry. So you can use this triangle to find anything per liter. You just have to cover whatever you need. So if you're finding mass, cover the mass, and then you know it's moles multiplied by molecular mass. If you need to find molecular mass, cover the molecular mass, and you know it's mass divided by moles. And if you want to find moles, you cover moles, and you know it's mass divided by molecular mass. Here I need to find the mass per liter, so I cover my mass. And now the equation tells me it's moles multiplied by molecular mass. So that's moles per liter, so that is 0.12 multiplied by the molecular mass of Na2CO3. We found it earlier, and that is 106. I'm so sorry, pardon, it's not Na2CO3 because we're finding hydrochloric acid. See, it's very easy to make mistakes. Hydrochloric acid, the molecular formula is 1 plus 35.5. Chlorine has a mass of 35.5 and hydrogen is 1, and that would give you 36.5. Multiply that, 36.5, and you will get 4.38 grams of HCl per liter. Again, that's rounded off to 2 decimal places, and that's your question done. And that was a solid 12 marks. So it's just the same as describing the entire theoretical part of it. That would have given you 12 marks as well. So that just shows you how important the mathematical part of it is. And I hope this video helped you to understand little tips and tricks. And definitely rewatch this as much as you want until you understand it. And I'll be making more videos for more complicated calculations like water of crystallization and other reagents, dilution factors in the future. So God bless, have a wonderful day or night, whenever you're seeing this, and I hope you score very high in your exams. And I say that because you deserve the maximum amount of marks that are possible. You would not be watching this video if you didn't want to improve and if you didn't have the commitment. So you deserve it, and I wish you the very best of luck for the future.